Hello, this is our presentation on predicting song popularity from audio features. To introduce our project, our research question is, are a song's audio features predictive indicators of its popularity? We used a data set containing 2,000 songs and their characteristics across 16 different variables, such as the duration of the song, energy, popularity rated on a scale of 1 to 100, and factors like tempo or key. We hypothesized that songs released more recently by more famous artists with higher tempo, energy, and danceability would have higher popularity scores.
One of the visualizations that we chose to do is a count plot showing the distribution of song popularity. The data follows an approximately normal distribution, slightly skewed to the left. The majority of songs are clustered in the 50 to 70 score range, representing moderate popularity. Viral hits in which scores were over 80 are rare outliers, meaning our model will primarily learn from mid-tier songs. Another visualization that we did is a heat map showing the correlation matrix of audio features. There appears to be strong internal correlations. Audio features show logical relationships, an example being energy and loudness having a correlation of 0.76. However, there appears to be a weak correlation with popularity. Surprisingly, no single audio feature has a strong correlation with popularity, as most scores are close to 0. The implication here is that song success is likely driven by a complex combination of factors or external marketing rather than a single audio characteristic. Our analysis shows us that explicit songs show a slightly higher median popularity compared to non-explicit tracks. There is also a significant overlap of the interquartile ranges of both groups. Our conclusion is that while explicit content might not align with certain popular genres, it is not a guaranteed driver of high popularity on its own. We found that songs are generally high energy and danceable. Explicit songs are slightly more popular, and some keys show slightly higher popularity, but effects are minimal. Correlations with popularity are near zero for all audio features, and no single audio feature reliably predicts popularity. So, what does it all mean? We can interpret that popular songs share broad traits, like energy and rhythm. However, the acoustic features themselves do not strongly determine popularity. From this, we can infer that popularity is likely driven by non-audio factors such as artist fame, marketing, playlisting, and algorithms. That being said, audio features alone are insufficient for predicting Spotify popularity. When looking at prior work, we found that high energy, BPM, and danceability characterize top charting songs. Our dataset shows similar general patterns, but it's likely that feature popularity correlations remain weak because prior work only focused on top performing songs instead of the full range, as well as the possibility that linear correlation may miss nonlinear or interaction effects. Limitations of the study may include a sampling bias, as the data is limited to Spotify only and may also overrepresent Western and/or pop music. We are also not sure how the 2,000 tracks in the dataset were selected. Genre and key are categorical values, but are stored as numbers in the dataset, which makes the data a little messier. Because popularity is algorithmic and not a direct measure of preference, measurement is a little vague. Lastly, because the data is observational, we cannot infer causation. Some ethical considerations for our project include Spotify's popularity metric reflecting possible platform biases based on promotion, playlisting, and geography. Limited metadata risks reinforcing existing cultural and/or commercial biases. Because of these ethical considerations, our analysis stays descriptive and avoids treating popularity as a universal musical preference. For future directions, if this project were to continue outside the class, we decided that we could test nonlinear models and create better categorical encoding. We could also analyze trends by genre or time period. Adding richer metadata like artist popularity, label, and playlisting could help us account for other contributing variables. Reframing prediction as classification based on low, medium, or high popularity can also make data easier to interpret. Our overall takeaway from this project is that audio features can explain broad patterns in general song popularity, but cannot predict individual popularity well. Popularity is a multi-factor socio-technical outcome, shaped by both music traits and external forces like algorithms, marketing, and culture.